All right, so today we're doing the rate of change. We're calculating what is called the average rate of change of a function between 2 points, which you have done with linear functions for years now. You've been calculating the slope on those. Okay, so when you're finding the average rate of change, it is going to be very similar to your slope. Okay, so they give you the equation for the average rate of change. Okay, it's this f of b minus f of a over b minus a. And they do tell you this would be for a function y equals f of x between x equals a and x equals b. Okay, really you just need to know f of b is an output when you plug in b. F of a is an output when you plug in a. Okay, so it's that same function notation that we've been using for f of x, right? F of x is the output, x is the input. So the average rate of change is your slope. Okay, so officially, it is this f of b. It's an output minus an output over the input minus an input. When we're finding that, I just write AROC for average rate of change. And you can apply it to points. Okay, so when you're finding the average rate of change of a curve, you're using 2 points on that curve, and the average rate of change is going to be the slope of that line. So if we compare this to what we're used to doing, your inputs, A and B, are like x1 and x2. Okay, your output, f of b, is the same thing as your y1. Or in this case, f of a and f of b. So if you want to think of this as y squared minus y1 over x squared minus x1, you can absolutely do that. Okay, so both of these are just ways to model the change in the output, okay, and the change in the input. Whatever variables they use, that's what we're doing. Okay, often you'll see the change in y over the change in x, right? And that's what that delta means. You're calculating the change of all of that. Okay, so this, and this are all the same thing. There's multiple representations. And so, for example 1, we are going to determine an average rate of change of the function between given values. Now, sometimes those values are on a graph, like in part A. So there's a few different ways you can find this. You could go ahead and label these 2 points. So this point is 1, 3, and this point here is 4, 5. And then you're finding the slope of that line. So you can think of this as your x1, y1, your x2, y2. Okay, so then we do 5 minus 3 over 4 minus 1, which would be 2/3. If they do give you the graph, you can use the rise over the run. So the rise here would be 2, the run would be 3. Just double check and make sure that when you're doing that, if it's going up, it's positive, right, it's positive. We can see the slope is going up, so it should be a positive value. Okay, so you don't even have to find the points if you have the grid. Okay, if you have the graph, you can use your rise over your run. Okay, but you're not always going to have your graph here. Sometimes you're going to be given a function. So we're given h of t is t squared plus 2t, and we're given two values for t. So the first thing that we're going to do is we are going to find our points. I like to use the point notation because it's something you're familiar with. So you can find the points with the given input values. Okay, so one input value is t equals -1. So I'm going to find h of -1. Once you plug that in, use your order of operations. So why don't you try that? Sometimes we second guess ourselves when we have those. And then go ahead and do the same thing for 4. So -1 squared is a +1. So this is 1 minus 2, which is -1. And then we're going to write our answer as a point here. Okay, and then h of 4, the second. So you have 4 squared plus 2 times 4, which is 16 plus 8, which is 24. So 424 is going to be our second point. Okay, and then you can find the average rate of change. You can just do the y2 minus y1 over x2 minus x1. And it doesn't matter which one you call your x1, y1, x2, y2. Okay, so I'm going to do 24 minus -1 over 4 minus -1. Anytime you have minus the negative, it's going to turn into plus. And 25 divided by 5 is going to be 5. So that is your average rate of change. Okay, so you're finding the slope between those two values. Okay, now for part C, this one is a little bit different because one of your input values is a number, but the other is a variable. So when that happens, you are going to be plugging in a variable. So we're going to start step 1 just like we did before. So I have x is equal to 1. So g of 1 is 1 divided by 1, or 1. So then let's write that as a point. What did I plug in? 1. What did I get out? 1. Okay, it just so happens that for this one and the last one, our input and output were the same. That doesn't always happen like that. And then for the second one, our input value is a. Our output is 1 over a. So again, you can think of this in point form. I'm writing it like that so that you can relate it to the slope because, again, that's something you've been doing for years, and it should be something that we're comfortable with. So when you do the average rate of change here, okay, if I do my y2 minus y1, I have 1 over a minus 1 over a minus 1. What we have to do from here is simplify the numerator to one term. This is exactly what we did in 1.4. See how these skills are going to be building on each other? So now that we know how to do that, that should be second nature for us. We're going to get the common denominator, which would be A. And then can you guys write what that's going to be there? Okay, so then in the numerator, you have 1 minus A divided by A. So 1 minus A divided by A over A minus 1. So once you have one term divided by another term, you can keep change flip. Okay, so if I keep the numerator, I change to multiplication. Remember, this is over 1. So when I flip, I have this. Okay, now if you can cancel anything out, we want to. And we can see here, these are both opposites, negative, positive, positive, negative. So when that happens, what do we want to do? Do what? Yeah, factor out the negative. Good. Okay, so we're going to factor out the negative. So if I do that, I have A minus 1. Okay, and if you couldn't factor it out, that's okay too. You could just multiply straight across. Negative times 1 is negative 1. Those canceled, so on the bottom I have A. This is going to be your average rate of change. Negative 1 over A. So if you have a number and a variable, the end here should be a variable. Okay, if you're plugging in a variable, you should get out a variable. The only time you wouldn't is if you had like 2 variables and you had some cancellations there. All right, now we're going to find out how old this book is because there's an example about CD player sale, which really hasn't been a thing for a while. I think I was still holding on to mine 20 years ago. So the table, which is here, shows the number of CD players sold in a small electronics store in the years 1993 to 2003. What was the average rate of change of sales between 93 and 03? So just like we've been doing before, we can think of these as points. So if I go to my table and I look for 1993, in 93 it says 512 were sold. In 2003, 584 were sold. I can think of that as an input-output situation. Okay, so in 1993, 512 were sold. In 2003, 584 were sold. Okay, so this is how you can think about it so that you can set up your subtraction. So your output minus your output. 584 minus 512. 2003 minus 1993. Okay, and for some of these you can use a calculator. This one you don't really need to because this is just 10. And then 84 minus 12 is 72. And if you divide anything by 10, just move the decimal. Okay, so it's 7.2 CD players per year. That's your rate. Okay, so the average rate of change is 7.2 CD players per year. Okay, and you are just going to use your normal rounding rules here. All right, and then for this one, we're going to do the average rate of change between 93 and 94. So we have 1993, here we have 1994. And we know on the bottom, there's just 1 year difference, right? So when we subtract that, we'll just have 1 in the denominator. This is another one where it's actually faster not to use your calculator. So your output minus your output over the input minus the input. 8 divided by 1 is going to be 8. Okay, so you have 8 CD players per year. Okay, so we just go ahead and do part C for the average rate of change between 94 and 96. Okay, so again, we know that that's a 2 year difference. So when we do 94 minus 96, we know we're going to get 2 on the bottom. Okay, so then it's 410 minus 520. That's a difference of 110, but it's negative. That's okay. What that means is there was a decrease between those 2 years. Okay, and I do kind of wonder what happened there because the MP3 players were not a thing yet. I think maybe anybody that wanted one had got one by then. It just kind of stalled. So we're gonna look at between which 2 successive years did the CD player sales increase the most quickly and decrease the most quickly. So we're gonna fill out this table and then I'm gonna assign like rows to find these so that this goes a little bit quicker. So 95 to 96, 96 to 97, 97 to 98, 98 to 99. Oh, that was when Miss Whipple was just a freshman in high school. And you guys weren't even born yet, were you? You guys 07, 08, 09. Okay. We'll have to do a fun activity one day. You guys can bring in pictures of when you guys are little. All right, so I'm just going to assign these. If you guys want to start calculating the first 2, you can. You guys are going to be in charge of 02, 03. Okay? You guys are in charge of 01, 02. You're in charge of 2000, 2001. The difference starts in 2000. 98, 97 here. 97, 98. 96, 97. 95, 96. You want to calculate more than that, you are welcome to. And because it's a consecutive year, you know what the denominator is going to be. Is 1. So you just have to calculate that difference there. All right. Brooke, what'd you get for 94.95? So it should be over 1. Should be, so from 94 to 95, it should be 413 minus 520 for this one, for 94 to 95. So if you do 413 minus 520. Oh, okay. Yeah, 95 to 96. And then 94 to 95 is negative 107. Okay, and then Andrew, what did your row get for 96.97? Oh, sorry. Okay, what did you guys get? 42. And then Alaria, what did you get? 96.97. Okay, what did you guys get? 58. All right, 98.99. Great. 99, 2000. 2000, 2001. Yes. Okay, 0102. Yep, good. And 0203. Negative 28. Great. Okay, so which one increased the fastest? 2000, 2001. Yeah. And then what about decreased? Oh, 102. Great. All right. Now we're going to move on to farms in the United States. So this graph is going to give the number of farms in the U.S. from 1850 to 2000. We're going to estimate the average rate of change in the number of farms between, and there's 2 that we're going to do. So from 1860 to 1890, 1950 and 1970. Okay, so what's nice about this graph, that last week's graph, that one that we had in our notes did not have, is these have different points here. Okay, so this is 1860, and what is the units going by? If this is 1860 and this is 1900? By tenths. Okay, so for part 1, we have 1890 minus 1860, so we know the denominator is going to be 30. Okay, and you can use your calculator for these, that is fine. Okay, and then in 1890, which would be here, you have this point. So we're just going to follow that point over. Okay, so it's at 4,500 minus at 1860, we're right here, which is at 2,000. Okay, so we're just going to divide. Sometimes I'll even, if I can cancel out the zeros, I will. All right, so it doesn't go in there evenly, so what did you guys get as your value? Jaden, did you get that? Yep. Okay, and then if it doesn't say what to round to, you can decide. You can do 83.3. You can say it's about 83 farms per year. And sometimes they'll want you to say whether it's increasing or decreasing. Okay, anytime it's positive, it's going to be an increase. Okay, and then for our second set, it's 1970 to 1950. So a 20-year span. So again, we are just going to find our point. Okay, and that looks like it's going to be right there at 3,000. And 1950. Okay, I'm just doing this to show you visually what I would be doing. Obviously, when you're doing this in your book, you would find your point, and then you would just go across. Okay, anything on that. So you have negative 2,500. You can use your calculator. You can also just divide by 10. Then you only have to divide by 2. When you cut that in half, negative 125. Okay, so that's our farms per year, and that is a decrease. Okay, so that is part A. In part B, they ask you in which decade. So a decade is how many years? 10. So in which decade did the number of farms experience the greatest average rate of decline? So let's look at our graph. If it's a decline, then it should be going down from left to right. So everything on this side of the graph is going up. Okay, and then we see them go down. The greatest amount is going to be the steepest decline. So between what 10-year period do you guys think? Yep, 1950 to 1960. Okay, so this is going to be the steepest decline here. So 1950 to 1960. All right, nice work. So I'm going to give you time to work on your assignment today. Okay, which means you're...
Excuse the announcement. Please allow students 3 extra minutes to get to class. Thank you.
And just remember, like when you're doing these, I am like looking for your work. So like even with these, just doing the 72 divided by 10 and then how you got that would be great.